Well, thank you for joining me on exercise 2B. I'm going to be looking at question 7. This is a colony of flying insects takes over a nesting site and the population of the colony grows such that n, the number of insects present, t days after taking over the site is given by n equals 500 minus 5t squared plus 10t cubed. We need to find an expression for the rate of change of n with respect of n with respect to time. So we do that by getting our dn dt, and so the derivative of 500 is 0. The derivative of negative 5t squared is negative 10t, because 5 times 2 is 10. Drop the power down, the index down to 1, and 10 times 3 is 30, and 3 drops down by 1 to 2. So there's part A. Part B says, what is the rate which the population is changing when t equals 1? Well, at 1 day, let's find out what the rate of change is. So dn dt after 1 day is negative 10 times 1, plus 30 times 1 squared, so it's 20. Now we have to put population insects per day. 20 insects per day is the rate of change at the 1 day mark. Part B, part 1. Now B, part 2 is when t equals 5, so we want the rate of change when t is 5, so we'll put a 5 in our variable. That's a 3, 5 squared. So it's negative 50 plus 30 times 25, and so we've got negative 50 plus 750, which is 700 insects per day. That's the rate of increase at 5 day mark. And finally at the 10 day mark, part 3, when t equals 10, the rate of change is negative 10 times 10 plus 30 times 10 squared. So it's negative 100 plus 30 times 100. And so we've got 2,900 insects per day. The n is the number of insects, t is a day, and so it's the rate is insects per day. That's the name of the unit of rate. I hope this has helped. Until next time, stay happy.